where it says draw a graph of the probability distribution and label the axis
Okay.
or the axes. Do you want something more specific than say like x and f of x, or is that all you want?
That's all. It's all I want. It's that simple.
Okay, no, I just wanted to make sure because that just seemed deceivingly simple. So.
Yeah, right, right. So it's just easy. Yeah. Uh, just want. I mean, I want to burn into your cognition the shape of the exponential density,
Okay.
and so having you have to draw it at least one time in your life, I guess is you know is one way to have that occur.
All right, thank you.
You need to basically have the correct y-intercept, and then if you understand what the general shape looks like, that's basically it.
Okay, cool. Thank you.
Anything else? Anything else?
This is just kind of like application based, but
Huh?
it's a question, right, about like the length of a long distance telephone call. When would that be useful in what company would want to use data like this?
Well, yeah, it's just a made up example. I mean, nowadays it used to be that long distance phone calls were a big deal. Nowadays it doesn't really seem to matter anymore unless it happens to be like an international call, you know? Um, so, I
But
mean, go ahead.
like what is an example of, like, not per se like this long distance, but what's an example of something that would be collected in this form that companies would want access to?
Well, any kind of company that has to set a price point for like what to charge customers, if customers are paying them based on if this event happens, I'm going to be in trouble and I'm not going to be able to pay for it. So like insurance companies, for instance, uh, need to charge their customers some amount, and they're basing that price point on how long they're expecting to like have to wait until a particular event occurs. And all of those models are built on the exponential distribution. The exponential distribution is kind of like the model of having to wait for some event to occur. And the way they can set it up is an insurance company, like for instance, Madeline, if you and I wanted to start an insurance company, nobody would share any information with us, okay? Because they would want to prevent us from entering the marketplace and kind of stealing part of their business. So what we would have to do, Madeline, is we would have to go and collect our own data about like how long, in this age demographic, how long do we have to wait for someone to like have a car accident or something? And how much does it cost on average, those car accidents? Okay. Or if we're in the, home insurance business, we would pay attention to, events on a house that we have to pay for. We would just kind of collect those sorts of data. We would, get it however we could. And then we would know, oh, on average, we're having to wait this long. And that would basically be our, 1 over lambda or whatever. And then we would say, okay, the distribution is going to be exponential because that's the distribution that describes like how long we have to wait till something occurs. And then we would build all of our models around the exponential distribution, and we would charge people monthly according to, the models that we've built. Is that kind of helpful?
Yeah, that makes sense.
Yeah. Exponential distribution is one of the most important distributions you run into in terms of applications. The normal distribution is probably the most important, but that's mainly because of the central limit theorem. So, yeah. All right. Good question. What else? Anything else? All right. Well, I am slowly getting caught up here. I'm sorry if you haven't gotten your exam comments back yet. I'm through a good deal of them, but I'm hoping to be done maybe by tomorrow or something like that. And yeah, so when did I say this homework quiz is due? Is that like midnight or something? Is that true?
Yeah, you said midnight.
Okay. Yeah. I'm going to start a new chapter in Olowski Dean. I'm not going to give any homework quiz on the data display stuff that I was doing. I just want you to know, how it works in general. And I think most of that is in the lecture and in the PowerPoint slides to the extent I want you to know it. But I'll probably cover a little bit on Wednesday and maybe give you a problem to work through either from a past chapter in Olowski Dean or a new chapter for you to just work on over the next couple days after that. And we're getting pretty close to the end here, but the next section will be on confidence intervals, using the central limit theorem to generate confidence intervals. So we'll discuss what that means and how to apply it in different contexts. All right? Yeah. You guys are letting me off the hook easy. So, but I'll let you guys get back to whatever it is that you were doing. Hopefully things are going well for you, staying on top of things. Appreciate you stopping by and shooting me some quick questions. And hey, just
Thank you.
Yeah, don't hesitate to send questions or anything my way if issues come up. All right? All right.
All right. Thank you. See ya.
Thank you.
See ya.
Thanks.